Identify the governing chemical principle. The energy required to separate ions in a gaseous state, lattice energy, is governed by Coulomb's law. E is proportional to Q1 Q2 over D, where Q1 and Q2 represent the charges of the individual ions, and D is the internuclear distance between their centers, which is equal to the sum of their ionic radii. The energy required to separate a pair of ions is directly proportional to the magnitude of their charges and inversely proportional to the distance separating them. Compare ionic charges, the dominant factor first. Examine the charges of the ions in each of the given options. Pair A, not to the power plus, and Cl to the power negative. Charge magnitudes are +1 and -1. Product of charges Q1 Q2 equals 1. Pair B, Cs to the power plus and Br to the power negative charge magnitudes are +1 and -1. Product of charges Q1 Q2 equals 1. Pair C, Mg to the power 2 plus and O to the power 2. Charge magnitudes are +2 and -2. Product of charges Q1 Q2 equals 4. Pair D, Ca to the power 2 plus and O to the power 2. Charge magnitudes are +2 and -2. Product of charges Q1 Q2 equals 4. Because the product of charges for Mg to the power 2 plus / O to the power 2 and Ca to the power 2 plus / O to the power 2 is 4 times greater than that of the +1/-1 pairs, their electrostatic attractions are vastly stronger, and they require significantly more energy to separate. This immediately eliminates options A and B. Compare ionic sizes, distances, for the remaining pairs. Now, compare pair C and pair D, which have identical charges, +2 and -2. According to Coulomb's law, when charges are equal, the pair with the smaller internuclear distance D, smaller ionic radii, will experience a stronger attractive force and require more energy to separate. Both pairs share the same anion, O to the power 2. Compare the sizes of the cations. Magnesium, Mg, is in period 3 of the periodic table, while calcium, Ca, is in period 4. Because Mg to the power 2 plus has fewer occupied electron shells than Ca to the power 2 plus, Mg to the power 2 plus has a smaller ionic radius than Ca to the power 2 plus. Determine the correct option. Since Mg to the power 2 plus is smaller than Ca to the power 2 plus, the distance d between the centers of Mg to the power 2 plus and O to the power 2 is smaller than the distance between Ca to the power 2 plus and O to the power 2. This smaller distance leads to a stronger electrostatic attraction, meaning Mg to the power 2 plus and O to the power 2 require the largest amount of energy to separate, which corresponds to option C. The correct answer is option C, Mg2 plus and O2 minus.